Thank you everyone for joining us today for our webinar on GuardLink Technology. My name is Chris Williams and I am going to be the co-host for this presentation. And with that, I am going to turn it over to Jim Bischoff to guide us through GuardLink Technology.
Thanks, Chris. Well, good morning, everyone. Thanks for attending. My name is Jim Bischoff. I'm the Automation Director here at Horizon Solutions. I work out of the Rochester, New York office and have been at Horizon about 25 years. Today we're going to talk about GuardLink Technology. Here's our agenda. We're going to kind of do a system overview, take a look at what the GuardLink system is. We'll talk about the components required to put a system together. We'll get a little bit deeper dive into the technology, kind of go through how this all works. We're going to give you an opportunity for Q&A. You should see an icon at the bottom of your screen similar to the one to the right there. Again, if you have any questions throughout this, submit them via the Q&A, and we'll probably be able to get through any questions you have at the end. Just as an aside, you know, this is not going to be a deep dive into safety standards. We're going to talk about how safety standards are impacted by GuardLink and other technologies. I'm not a safety specialist. We have several TÜV certified machine safety specialists at Horizon. We will have a couple of them on the call at the end in case you ask a question that's over my head, but we'll be able to address it. So let's get into it. So what is GuardLink? Well, as the title of the seminar implied, you know, it's a simple way to get diagnostic data from standard safety inputs with no configuration required and with no loss of your safety rating. And as you'll see, and we'll have this several times, we do support up to performance level E. So typically, people utilize series connections for devices. And with series connections, you lose the diagnostic granularity, which may lead to some unnecessary machine downtime. GuardLink helps solve that. And again, the diagnostics that you get is really critical for recovering from safety demands quickly. So let's take a look at how a series wired safety solution might work. And if you follow this cartoon at the top of the screen here, you'll see that our tower light indicates that we have a safety demand on our system. But as you follow this along to the right, you'll see we have a relatively large assembly machine here. And my technician here in blue starts walking around looking for where the safety demand might have come from. And he begins checking the guard doors and the E-stops. He enlists his buddy in green there, and they eventually get around the system and hopefully find where that demand came from, but you'll see that it could have taken quite a bit of time to find that. Well, there's got to be a better way. So some other ways that we might do that today is we wire these individual safety input devices, our guard door switches, our E-stops, what have you, into the input of a safety controller. Perfectly acceptable. It would be a higher cost way of doing things, and it might be what you'd want for the situation, but it is definitely going to add some cost. Another way is we could add wiring for the aux contacts of our safety devices, wire that back into traditional inputs into a controller. But again, that would require a lot of home run wires or distribution blocks. And unfortunately, not all safety devices ever made actually have aux contacts, so that could be an issue. And again, GuardLink is going to help solve that. problem. So what does GuardLink look like? Well, here's kind of a typical system overview of GuardLink. We're using standard safety input devices. So you'll see our non-contact guard door switches, our locking guard door switch, an e-stop button. The smarts of this is in the tap, not the devices in this drawing. So our GuardLink smart taps are shown. We have a terminating plug that tells our GuardLink master that there are 4 safety devices on our system. There's our GuardLink master. We have, in this case, an Ethernet adapter that goes back to a logic controller. Notice in this case, the logic controller is a gray controller, not a red one. GuardLink does not require the use of a safety PLC. And then we have an HMI where we would be able to enunciate the diagnostics and also initiate some commands. The devices themselves, most of our modern safety input devices have some indicators on them. In these cases, they have an indicator of their state. The smart taps, the GuardLink taps, also show the state of the inputs. So we would see the state of our e-stop in this case, even though it may not have any indicator on it. And then the GuardLink taps also have a state for the link itself, the network state, so to speak, on them. Our relay also gives us indication of the status of the link. So let's go through a typical scenario in the real world. So here's a case where we've created a safety demand. We've opened a guard door. And again, in a series wired solution, even though this looks kind of like a series wired solution, we provide additional diagnostic information, which in this case is passed through the safety relay through Ethernet to our controller, which allows our panel view to show that the guard door 1 switch is open. When we do whatever we need to do, clear the jam, or for whatever reason we open the guard door, when our link is satisfied, we're now okay to run. In a similar scenario, if we were to press an e-stop, that tap would show that the e-stop is pressed by its input state turning red. The other ones, as you see, are flashing green. And the GuardLink relay would tell the controller through Ethernet that input 4 has changed state, and we can enunciate now that the e-stop has been pressed. And again, once we pull that e-stop switch back out, we can go back into a okay to run state. And we do all that by maintaining safety integrity level 3, performance level E, or category 4, depending on which standard you follow. So let's take a look at some of the specs for the system. Well, it's a trunk line, drop line technology. The trunk line is a standard 4-wire trunk, so GuardLink is a 4-wire network, and the drop lines are either 5 or 8-wire conductors. We use standard safety input devices. In this case, we've got a standard e-stop or a standard guard door lock, and we support either electromechanical switching devices or solid state switching devices. We can have up to 32 GuardLink taps or GuardLink inputs per link, and we allow up to 1,000 meters of link distance overall with a maximum of 30 meters between the taps. And then each tap can have up to 10 meters from the tap to the switching device. This GuardLink DG safety relay, that DG stands for dual GuardLink. We actually support up to 2 links per relay. So that would allow us 20,000 feet or 64 switching devices per relay. And again, we're going to keep reminding you, we still can meet up to PLE, SIL 3 PLE. Now we add the smarts to get this information over to our standard Logix controller. Here we show the Ethernet IP interface. Our logic controller, which has an add-on profile, which essentially automatically configures the system in the controller and generates the tags required to use GuardLink. And then we use our HMI to not only indicate where we have a safety demand, but it also allows us to do some remote resets. We can do locking and unlocking of guard locking devices, locking, solenoid type devices over the network. So let's talk about series wired. We went through a scenario with the cartoon at the beginning that talked about series wiring being harder to troubleshoot because you don't know where your safety demand came from. Another issue with series wired safety devices is that there is the possibility for fault masking. And a recent change to the ISO 14119 states that if there's any possibility of fault masking, then the highest safety rating you could achieve is SIL 3 PLD. So if you are trying to achieve performance level E, you cannot do that with series wired devices. All right, so here's kind of a summary. So what GuardLink does is it allows us to use standard safety components and get diagnostic data from them. And really we just can't do that with a direct connection over Ethernet. We can't really afford or have the real estate to embed SIP safety into something simple like a FerroGuard. So we need another way to take these simple devices and get that information from them. We use a daisy chain topology, simple M12 connectors, and we support not only the reset functions and the diagnostics, but also locking and unlocking over Ethernet, which brings us to a poll question.
Thanks, Jim. So we're going to have a quick poll question for you guys, and that is, what type of locking safety interlock do you use? Our options are power to release, power to lock, both, or neither. We'll give you guys another few seconds to answer this. Still got some answers trickling in, so we'll wait another few seconds for everyone to get their answer in. All right, another 5 seconds. Those last minute answers. All right, and here are the results.
Okay, thanks, Chris. So interesting that power to lock is the most common, but many people use both, and some don't use either. So really good results, and we'll go into that a little bit more as we move forward on how we support those different locking types. So thanks. So let's talk about the components to make up a GuardLink system? Well, it starts with the safety relay, the DG, or the dual GuardLink relay. And there's a whole bunch of specs here about what this guy does. In fact, it does can do up to 20 different functions. Really, in this case, we're interested in obviously its ability to support GuardLink. We do have the relay outputs. These are the dual positive guided outputs, so we can handle higher loads on the output side of this. We can expand this and add additional outputs. We can also communicate through and have multiple of these GuardLink relays as well. Then we have the taps. So this is kind of the smarts. This takes our standard generic safety input devices and now gives us that diagnostic there. We're using standard M12 connectors, either the 5 or 8 pin. And again, we support the solid state or electromechanical inputs. It also supports the guard locking devices. That's what we just had the polling question about. So you can lock a door so that an operator can't open it for obvious reasons. It does provide the device location automatically. As we talked about, the GuardLink is self-configuring, so the first tap in the system becomes node 1 and so on up to the last one, up to the 32nd one. We talked about the indicator lights on here. One interesting note, it is designed to fit on standard strut, and it does have up to an IP67 environmental rating. This one we didn't show in the earlier slide, but we do have something called a passive power tap. The passive power tap is there in large networks. Remember, we can go up to 10,000 feet. And this is put in place to overcome issues of voltage drop. So this device, as you see when it's installed, allows you to add an additional power supply to power the downstream devices. It also has the ability to support a GuardLink enabled device. So far we've talked about standard devices, but in the future we're going to be putting the GuardLink technology directly into the device. And when we have those, we'll be able to add the GuardLink devices into this. Or if you don't have that, you would just install the shorting plug that you see in the drawing. And you can see we can have up to 7 of these on a single link. Well, how do you know if you need a passive power tap? Well, we have a voltage drop calculator that you can either get from the Rockwell knowledge base, or if you use ProposalWorks, you can get it from ProposalWorks. And essentially, you can then add your safety devices and the lengths of cables. It will calculate the voltage drop for you and then let you know if you need to add additional power taps and power supplies to your system. We talked about the future of smart GuardLink enabled devices. Well, if we want to mix and match these smart devices with our standard other devices, we could use a passive tap. So in this drawing, you'll see a GuardLink enabled device, a 440GMZ, which is coming soon. And if you want info on that, contact your safety specialist. But that allows us to mix and match our standard devices with our soon to be available GuardLink enabled devices. Okay, well, we also then would have the Ethernet IP interface. This has two Ethernet ports, so it has essentially an embedded switch which supports our DLR ring technology. It does support does also have the rotary switches. So if you're using, you know, our standard non-routable 192.168.1, you can utilize these switches to set the last octet of the IP address. You'll see it does support control flash. And then you'll see it also supports up to 6 GuardMaster safety relays through an optical connection. So interesting, you know, why would we have multiple GuardMaster relays and possibly, well, it's one obvious reason would be we support 2 links per relay, 32 devices per link. So if we needed more than 64 devices, we could use one Ethernet interface to have multiple guard relays. But if you've been around the safety world, you know, recently and maybe even a couple weeks ago, Tom Hopkins did a webinar on safety control. You know, people are looking at safety differently today, and our modern contemporary safety solutions are put in place to enhance productivity, not limit it. So if you had multiple safety zones in your system, you could add multiple GuardMaster GuardLink relays and do some simple zone control. So for example, if you needed to clear the jam on the in-feed part of an assembly machine, you may not need to kill all the other zones. They could continue to run and not have scrap. So in that case, you could have multiple GuardLink relays and do some simple zone control. Normally we think of zone control and safety PLCs, but this provides another solution without the need for a safety PLC. Good retrofit opportunity. So, and then we have the Logix integration. So with the Logix integration, we do require version 20 or higher. This is automatically configured for you when you add the add-on profile. The tags get populated. So essentially it's self-configuring. So let's take a peek under the hood, so to speak. We talked about the trunk line being a 4-wire system. That's what's on the 4 wires. We have our 24 volts. We have our command lock and unlock connection, and then we also have the GuardLink. And the GuardLink is where we have a digital signal that we can do multiple purposes. So in this case, you'll see a safety pattern that's being generated from the GuardLink tap based on the device that took to it. So there you have the master that processes the data and passes it back to the PLC, and then our smart taps, which pass the data to the master. And again, the GuardLink wire is safety and diagnostics on the same wire. So what does that look like? Well, in A, you'll see that under normal circumstances, where there's no fault or safety demand, all devices send their unique safety pattern, and then the GuardLink relay says that we're okay to run and passes that information to our logic controller. When we get a demand, the device with the demand, the tap stops sending the safety pattern, which then causes the relay to say, hey, what's going on? So it sets a signal for all devices to report their status. In this case, device 1, 3, and 4 say that they're satisfied, but device 2 says it's in a demand state. And then in the third example, we're actually showing a fault. A fault would do the same thing. It would terminate the safety pattern, and then we would assert the command block unlock line for the device to tell us their status, and in this case, device 3 tells us it's in a fault state. Okay, so we talked about the ability to lock and unlock, and everyone looks like based on the poll, people use a mix of lock and unlock. So here's the use case today for unlocking a locking guard door device. So in this case, we have the HMI where we could initiate the unlock command. When that happens, we actually are first off checking to see that we're in the correct state. That signal gets passed. And again, as we talked about the GuardLink line, we're able to do both commands and status on that. And then assuming everything is in the right state, we send the unlock signal to the device, in this case, node 3. So a couple things to note as you look through this. We actually have individual unlock or lock commands, or all lock unlock commands. So that's up to you and how you send that through the controller. If you do unlock all, then we actually automatically put in latency time between the different nodes so that we don't put a big current demand on the network and cause a voltage drop. And the last bullet here, so up until we got into the locking and unlocking, you could conceivably use a GuardLink system without a logic controller, and there would have some merit based on the indicator lights and some of the other things that we talked about. But if you want to use locking and unlocking, you do need to have the Ethernet interface and a controller. So what about locking? Well, that's coming soon. Many people feel that a power to release is a safer system because I can wait for any residual energy in my system to stop movement or rotation or whatever it is before I unlock. But in other scenarios, sometimes we use locking to actually prevent scrap. Sometimes a controlled stop or a cycle stop makes more sense than just yanking a guard door open. There's always an e-stop function for that. So sometimes we want to prevent operators from causing scrap by locking. So power to lock is coming soon. We'll have that this summer. It'll use all the same components that you saw today, and it will be a flash firmware update to the GuardLink safety relay. A couple of items of note is when you set up a GuardLink link, you remember the relay has 2 that it can support. The link itself will need to be configured for either power to release or power to lock devices. Essentially what that means is on the same link, you can't mix and match power to release and power to lock. And once we support power to lock, we will then have support on GuardLink for a new electromagnetic safety switch, the 440G-EZ. And again, if you want more information about the 440G-EZ electromagnetic device, contact your Horizon safety specialist. Okay, so with that, in a second here, we're going to go through any questions that you had. I do want to point out a couple things. We do have more of these webinars coming up. We've had a very successful series of drives presentations along with safety presentations, and on the next week we have selecting a drive with ProposalWorks. So selecting and configuring that Scott and Kevin will be hosting, and then we also have our safety team talking about returning to a safe workplace after the coronavirus pandemic. And I also want to point out, you may have seen in the bottom left kind of a new shopping cart logo next to our horizonsolutions.com. We do have a brand new website. You can shop on our website. We have a few 100,000 of our most popular items in our store, and I wanted to make you aware that that is now available. With that, Chris, do we have any questions?
Hi, Jim. Yes, we do have a few questions lined up that we'll go through. The first of them is, can I install a light curtain on a GuardLink tap?
Yes. Yeah, the GuardLink or the light curtain is typically going to be an OSSD type connector, a standard input that we can put on a GuardLink tap.
Perfect. Next question we have is, so this system controls the input side of the safety system. Since it can be connected to a standard PLC, how is the output side handled? For example, safety relays to cut power with monitoring.
Yeah, so it's really installed, and I may lean on either Mark or Tom to augment my answer here, but it's installed as you would any safety circuit. So the switching device is this relay with any expansion. Tom or Mark, do you want to elaborate?
You have it correct, Jim. It's exactly like a normal safety relay. And the DG also has a monitoring circuit. So if you were going to, let's say, a contactor or a control relay, safety rated control relay, you also have integrated monitoring.
Thank you.
Perfect. So the next question is, so this is only for one safety action. For all the switches in the circuit, there is only one output to initiate the safety action?
Per relay. Yes. If you wanted multiple safety zones, you would need multiple relays. Again, you can have up to 6 per Ethernet adapter.
Perfect. And the next question is, for each of the devices, for example, an e-stop or a door switch, do I need to assign an address to each device? Does the system recognize automatic device recognition? So,
an interesting question. So when you configure a GuardLink link, the devices are automatically numbered from the GuardLink relay. So the first tap becomes node 1 on link 1, for example, up to the 32 devices. That information, once the terminator is put on the network, the relay knows that there are, in the drawing you saw, 4 devices or 20 devices, and that becomes their node address. There is no, in the true automate, the device configuration is not required for this, because all the information is in the safety relay, which configured the system automatically.
Perfect. Another question, how does the number of links affect the response time for evaluating against safety stopping distances?
So that's a great question. It's an interesting question as well, because series wired devices you would think would be faster. However, depending on what type of device they are, if they are dry contact devices, they will be faster, because now we're just dealing with the speed of electrons. But solid state devices actually have to, if you think about it, they have to process an input and retransmit an output. So every OSSD device has a latency time associated with it. On GuardLink, they're not additive. In series wired, they're additive. So if you had 20 OSSD devices series wired, the response time would be slower than those devices on GuardLink. We do actually have some spreadsheets that show that, and how we would use, you know, how we would calculate response time, so we can, you know, do safety distance calculations. But for OSSD devices, GuardLink likely will outperform series wired.
Thanks for that answer. And I think we just have one more question, unless anybody else chimes in shortly. If I don't have Ethernet on the machine, can I still use GuardLink?
You can. You would get the benefits of the visual indicators that you get on the taps. However, you cannot do the remote lock, unlock, reset commands. Those do require the Ethernet interface to a logic controller.
Perfect. I think this last one that came in is similar to that, but I'll read it just in case you want to elaborate a little more.
Chris, I think I lost you.
Jim, I think the last question, I don't know where Chris went.
Okay.
I think the last question is, do you need a safety PLC with outputs to use the GuardLink system, or are the outputs on the safety relays? I think, did we answer that already?
Well, we did, but let's just make sure everyone understands. A safety PLC is not required. You could use one, but it's not required. As Mark mentioned, the monitored outputs are a part of the safety relay. So typically a standard compact logics or control logics controller, a gray one, can be used with GuardLink.
I believe that's the last question, Jim.
Okay. Well, I'd like to thank everybody for joining us, and again, look forward to you joining us also on these future webinars you see on the screen. Thank you.